Look at the top right corner of your screen to see the question mark button. This is the question mark button. Now you can avail this question mark button at any point of time in the session. Whenever you feel like asking any question or there is any doubt or any concept that troubles you, without any hesitation, you can reach out to us by clicking on this button. Then a chat box shall come on your screen. You can type out your doubts there. After every few subtopics, we'll be catering to your doubts and the remaining doubts shall be taken towards the end of the session. So let's quickly get started. But before getting started, may I please get a confirmation from all the students so I'm clearly visible, I'm clearly audible, and the screen is visible to everyone. So that we could move ahead. Students? Okay, and we can see that we have got a very healthy count of attendance today. So expecting for a very healthy participation from all the students here, okay? Okay, very good students. Let's get started. Now what are all going to be the learning objectives for today's session? What are all going to be the things that we are going to learn today? First, we'll understand the concept of equivalent fraction. Okay? Then we'll learn about like fraction. In like fraction, towards the end, we'll develop an understanding about how to compare the like fractions and how to compare the unlike fractions. So, is it clearly understood till here? Moving ahead. Before soaring ahead in this session of session 2, we need to recall and recount about the concepts that we have already learned in the previous session. Because then only, based upon the consolidation of the concepts that we get from there, upon that foundation only we could cruise ahead in the session 2. So, what is the very basic concept, or what is the very basic fundamentals of fraction that students know? May I please get a response in the chat box? Yes, students, quickly. I need a response in the chat box so that I could see that what the basic understanding that students have of this topic. What is a fraction? How are we going to define a fraction? Because fraction is something that we have already understood in the previous session. That's just a recalling of the things from the previous session. So very good students. Fraction can be widely said as part by whole. So now once again, we'll be giving the example of a pizza. We have a pizza and this pizza has been divided into 4 equal slices, or you can say 4 equal pieces. And now this pizza is to be divided among 4 friends. Now each friend gets a slice. So what is the share, what is the fraction share of each friend in this pizza? So if we go by the principle part by whole, total of 4 number of in the whole of pizza, and the part that each student or each kid gets, that is 1. So 1 by 4 is the fraction correspondence of each, or you can say the fraction share of each person who is having a share in this pizza. So this is how we define fraction. So I hope that most of the students are, in fact everyone is able to recall the concept of what basically a fraction is. Then after we understand what a fraction is, we go to proper fraction. How do we understand a proper fraction? In a fraction, we have a numerator and we have a denominator being separated by a vinculum bar. This is the vinculum. Here we have the numerator and here we have the denominator. So students, let's focus upon numerator and denominator. Proper fraction says that the numerator must be less than denominator. So all those fractions where the numerator is less than the denominator, such fractions are called the proper fractions. Just remember this thing. The numerator must be less than the denominator. Isn't it, students? Keep getting the responses from students, and we could get to know that there is a participation from both the sides. Very good, students. Now, what is improper fractions? Improper fractions are those fractions where the numerators are either equal to the denominator or they are greater than the denominator. So, numerators are either greater than or equal to the denominator. So, it's better that we start taking examples. Proper fraction could be any fraction where the numerator is less than denominator. We could say 9 upon 10. We could say 10 upon 15. We could have 11 upon 20. We could have 3 upon 4. All these fractions are an example of proper fractions. But what were improper fractions? Remember, students, from the session 1, where the numerators are greater than or equal to denominator. So the examples would come like 5 upon 3, 3 upon 2, 3 upon 15, or you could say 31 upon 17. I mean, in all these examples, you can see very clearly that the numerator is greater than denominator. Okay, so now there is a question. Is 1 equals to 1? Is it an improper fraction or not? May I please get the responses from the students? Okay, so very good, students. I'm getting very mixed responses from the students. So remember one thing. We write 20, then that means 20 by 1. If I'm writing any number, then automatically there is 1 in the denominator. If I'm writing 1, then that too means 1 upon 1. Now, in 1 upon 1, we can see that numerator is equal to denominator, isn't it? And numerator equal to denominator is a case of improper fraction. Thus, we can say that 1 is also an improper fraction. So, is there any doubt to any student in this concept that 1 is also an improper fraction? Okay, very good, students. Now, what are mixed fractions? So, the concept of mixed fraction arises the fact that if we are having 4 cakes, or let us say we are 3 friends who order 4 pizzas. Now we have ordered 1, 2, 3 and 4 pizzas. There are 4 pizzas that are meant to be shared among 3 friends, and only 3 friends are there. Okay, and now rule of law, 4 cakes have to be equally divided among these 3 friends. You cannot say that one friend is going to take 2 pizzas and the remaining 2 friends are going to take 1 each. No, it has to be divided equally, because in fraction also, when you used to draw a pizza, in the basic definition of fraction, we always divide the cakes or the pizza or whatever we have, the plum pudding, into equal pieces. You cannot say that if this is a cake and it is divided in this way, 1, 2, 3, 1, 2, 3, 4, 5, then the fraction of this one particular piece is 1 upon 5. No, because this cake has not been equally divided. The fraction applies only when you are dividing equally the pieces of the cake. So here it has to be divided among 3 friends. So what can they do? So let us say, friends suggest, let's do one thing, let's start eating 1 cake each. This is being eaten by one of the friends, this got eaten by the second friend, and this cake got eaten by the third friend. So now each friend, 1 complete cake. Now they were left with 1 more cake, so towards the end, decided, now after eating 1 cake each, they can do one thing, that they can divide the finally left after cake into 3 pieces. So this finally left after cake also got divided into 3 equal pieces, 1, 2 and 3. What is the fraction share of each friend? It is 1 by 3, because if we apply the concept of part by whole, that will become 1 by 3. So they ate 1 complete cake and then they ate 1 by 3 more. So what is the fraction of the cake that each person got, or each friend got? That is 1 plus 1 by 3, which can be written as 1 whole 1 by 3, and this is the form, students, stay focused, this is the form which is called the mixed fraction. Do you get, students, the concept of mixed fraction? So now very clearly you can see one more thing. They already had eaten one cake, and then after eating one slice more, they have eaten technically more than one cake. And now since they have eaten more than one cake, it means the fraction is in improper form. Because proper fraction says fraction must be less than 1. And the improper fraction says it must be greater than or equal to 1. This is what we have gained from the session 1. Fine, students? Now, on one hand, we say that 1 whole 1 by 3 is a mixed fraction. On the other hand, we also see that since it's greater than 1, 1 plus 1 by 3 can be in improper form also. There were 4 cakes which was divided. Those 4 cakes were divided among 3 friends. So the fraction that each friend got is 4 upon 3. Now 4 upon 3 is clearly an improper fraction form. Because 4 is greater than 3, the numerator greater than denominator, and hence it's improper fraction. So now you can very clearly see that when written in the form of 1 whole 1 by 3, it's mixed fraction, and when the same fraction is written in the form of numerator by denominator, it is an improper fraction. It means there can be an interconversion, it can be possible. So moving later, in the previous session, we learned about how to convert improper to mixed and how to convert mixed to improper. That is very easy. Look, if we have 1 whole 1 by 3, what we got to do, you divide the denominator by the whole number part, that gives 3 multiply 1, then you add the numerator to it, plus 1. It becomes the numerator, and the denominator remains the same, that is 3. So when you solve, what do you get? 3 ones are 3, plus 1, 4. And the denominator is 3, so you can see 4 upon 3, which is the same as we saw above. So these are all the things that we have learned in the previous session, and how to represent fractions on a number line, a very interesting part that we learned in the previous session. So let's quickly recall how to plot fractions on the number line. Suppose you have to plot 1 upon 3. So what we are going to do, this is 0 and this is 1. Then you will mark 3 equal divisions in between 0 and 1. Okay? 1 division, 2 division, and the 3rd division. Now you start writing this as 1 upon 3, this becomes 2 upon 3, and this becomes 3 upon 3, that is technically 1. So this corresponds to 1 upon 3. The first mark of all those 3 marks in between the interval of 0 and 1 corresponds to 1 upon 3. Similarly, if someone asks you to present 2 whole 3 by 4, how to represent 2 whole 3 by 4 on the number line? Very easy. 0, this is 1, this is 2, this is 3, this is 4. Now 2 whole 3 by 4, it means 2 in whole number parts, then 3 by 4 more to it. So first you go to 2, and then in between 2 and 3, because 2 whole 3 by 4, as you can just understand it simply by looking at it, the 2 whole 3 by 4 will lie in between 2 and 3. So we'll make 4 equal divisions, because 4 is the denominator of 3 by 4. We'll make 4 equal divisions. 1 part, 2 part, 3 part, and 4 part. Now, 3rd division of it, 1, 2, and 3rd. This is the 3rd division. So 4 intervals that have been marked in between 2 to 3. This corresponds to 2 whole 3 by 4. Okay? Now, I hope the concepts of the previous session are very much clear with the students here. If yes, then do give me a response so that we can quickly move ahead to the next part. Students. Students are waiting for all the responses, and we shall move ahead only once we get the response from everyone here. All the students, we've got a very healthy count of attendance today, as you can see. Why is it that very few students are giving the response? Okay, very good students. So now all the students really understood the concepts of this session 1. Now we shall quickly move ahead to our session number 1. Now in this, now we'll quickly move ahead to session number 2. Students, what is the first topic that we are going to pursue here? That is the concept of equivalent fraction. Okay. So what are equivalent fractions? As you can see here on the screen, students stay focused. As you can see here on the screen, we have got 4 circles here, or let us say 4 pieces of cake. 4 cakes, 4 complete cakes. That would be better to understand. Okay. Now what happened? In the first cake, you made 2 divisions, that you divided the cake into 2 equal halves and you took one piece of that, one that is being shaded here. What your other friend did, he divided the cake into 4 equal parts, but after dividing the cake into 4 equal parts, he took 2 pieces of it. Okay. Now after seeing both of you guys, your third friend decided divide the cake into 6 equal parts. Something new. So he divided the cake into 6 equal parts, and upon dividing the cake into 6 equal pieces, he took 3 pieces. One that is being shaded here. Okay. Okay. Now similarly, the one sitting at the corner in the room, he decided to go to another level. He divided the cake into 8 equal pieces, and then he took away 4 pieces from it. Now these are the 4 pieces that are being shaded here. Went into that 4th friend's part. Now students, you yourself tell who ate more. You ate more, or your first friend, or your second friend, or your third friend. This is you. This is your first friend. This is your second friend, and this is your third friend. So students, quickly give me the response in the chat boxes. Question is, who ate more? Okay, very good. I've started getting the responses in the chat box. So students are saying that everyone ate equal.
Yes.
Okay.
Equal. All equal. All half circles.
It means that doesn't matter. We divide the cake into 2 equal pieces, 3 equal pieces, or 5 equal pieces. 6 equal pieces, 8 equal pieces. However, how many equal pieces we divide the cake into, still we could get the same share of the cake. Look, this represents this fraction. Representation is 1 upon 2. Fraction representation of the first friend is 2. Therefore, then the fraction representation of the third friend, the second friend is 3 by 6, and for the third friend it's 4 upon 8. Now, if the students here are saying that everyone ate equal, then technically you mean to say that 1 upon 2 is equal to 2 upon 4 is equal to 3 upon 6 is equal to 4 upon 8. Isn't it? Isn't it what we are trying to say here, or what we are perceiving from here? Isn't it what it exudes from here? So now it has been clearly written here that if we look at the fractional presentation, they look different, but all are representing the same part of the circle. Though it may look different, the cakes have been divided into different number of pieces, but end of the day, the fraction representation they are or that they correspond to are all the same. 1 by 2 is same as 2 by 4 is same as 3 by 6 is same as 4 by 8 because they all are half. So what do we get from here? We get a trick from here that to find equivalent fractions. It means if all these fractions are same, so we give a term equivalent fractions to them. That has equivalent term that has come out from the term equal. How do we get equivalent fractions? If we multiply the numerator and denominator of the fractions by the same number. So here we can look very clearly. 1 upon 2 is the fraction. Now when we multiply the numerator by 2 and also the denominator by 2, what do we get? The numerator becomes 2 and the denominator becomes 4. So this is an equivalent fraction. Yes, students? Any doubt? Okay. In the same way, we can say that in 1 upon 2, if you multiply the numerator by 3 and then the denominator also by 3, the numerator is going to become 3 and the denominator is going to become 6. It means 3 upon 6 is also an equivalent fraction. So if the final verdict what we get from the slide is that if you multiply the numerator and the denominator the same number, you're going to get an equivalent fraction of that fraction. Now let's quickly move ahead. An example has been shown that for 2 by 9 the equivalent fraction can be very easily found by multiplying the numerator and the denominator by 2. 2 multiplied 2 becomes 4 and 9 multiplied 2 becomes 18, thus 4 by 18 is the equivalent fraction form. Let's come to equivalent fractions of 5 upon 6. To find the equivalent fractions of 5 upon 6, so what if we multiply the numerator by 2 and the denominator by 2? That becomes 5 multiplied 2 is 10, 6 multiplied 2 is 12, and thus 10 upon 12 is the equivalent fraction. We can find many such equivalent fractions. In fact, we can find countless number of equivalent fractions. We can multiply both the numerator and the denominator by 3. We are going to get 15 in the numerator and 18 in the denominator, isn't it, students? Do you have any other equivalent fraction that you want to include it here in this session? If there is any doubt, anything that troubles you, any concept that troubles you, you reach out to us by simply pointing out the concept that is not able to be understood by you. Okay? Now we can say 5 upon 3, the fraction, then 5 upon 6 is the fraction that is given to us. If we multiply the numerator and the denominator by the same number, we get the equivalent fractions of it. So what if we multiply the numerator by 4 and at the same time the denominator also by 4? So we are going to get 20 in the numerator and 24 in the denominator, that's 20 by 24. If we multiply numerator, let us say we'll multiply by 10, both the numerator and the denominator. So we'll get 50 in the numerator and 60 in the denominator, thus 50 by 60 is a new equivalent fraction. Much of equivalent fractions. Now let's move ahead and coming to like fractions. So what are like fractions, students? Like fractions are those fractions which have the same denominator. Okay, where denominator represents number of whole parts. It means when you're having number of whole parts as same and numerator keeps on changing, this becomes the like fraction. 5 upon 6, upon 6, 1 upon 6, 3 upon 6, upon 6, 100 upon 6. Like in all these fractions, what is the one thing that we can see as common is that the new denominator is all the same. In all these fractions, in all these cases, the denominator is 6. So when the denominators are same, fractions are said to be like fractions, as has been clearly written here. Fractions with same denominators are called like fractions. So is there any doubt to any student in the concept of like fractions? Any doubt? Anything that troubles you guys? Because in the picture representation also, we have been very clearly shown in the first case, represents a look, the total number of pieces are 1, 2, 3, 4, 5 and 6. But the one that has been shaded in the blue color, the fraction representation of that part is 1 upon 6. Isn't it? Similarly, in the second representation also, we've got 6 pieces all in all, but this time 2 pieces have been shaded blue in color, so it becomes 2 upon 6. Now, third case, again we have 1, 2, 3, 4, 5 and 6, and only one. By 4 or 1 by 4? Quickly, students, that's very easy. Yes, 2 by 4 is greater than 1 by 4. Here we can very clearly see that the denominators are the same. Okay? Now since the denominators are same, in both the cases they are 4, the only thing that we got to do is simply compare the numerator, and the one with the greater numerator is going to win the game. So in 2